Hello viewers, in the last two episodes we have discussed the tsunamis, their cause and the effects. As we have discussed earlier, the warning systems, they are feasible in case of tsunamis. In this episode we will discuss the warning systems deployed worldwide and with particular example in Indian context. Now we will see one of the important aspects of tsunamis, that is the warning systems being used for this damage causing phenomena. Why the warning systems are used in case of tsunamis and not in case of earthquakes? It is because of the lead time available to the user. Like the seismic waves have the speeds of around 5 km per second, while the average speed for tsunami waves is only around 200 km per hour. Now, this difference gives a lead time to the public at the coastal regions to prepare themselves or go away from the coastal regions. Most of the tsunamis are caused by earthquakes. Then, if we can record and tell the people that the earthquake has occurred, it may generate tsunami, then the life and the economic loss can be saved at the coastal regions. The great destruction caused by the 1960 Chilean earthquake tsunami prompted a lot of countries to join the Pacific warning system for tsunamis. Then again, after 4 years, there was the Alaskan earthquake. So, most of the countries at the rim of Pacific Ocean, they joined the tsunami warning system. In 1965, after the 1 year of the Alaskan earthquake, UNESCO recognized the importance of the tsunami warning system, and the offer of USA was accepted, and the tsunami warning system used by Americans was made as International Tsunami Warning System. We call it International Tsunami Information Center, ITIC. The headquarters of this ITIC is in Hawaii. ITIC mandate has evolved over the years. The function earlier was to give the information of the tsunamis to the state members, give them the preparedness guidelines and the awareness for the tsunamis. The ITIC functions now are ensuring the dissemination of tsunami watches and warnings and collection of tsunami information on a real-time basis, giving technical advice on the equipment required for an effective warning system and providing assistance in the establishment of national warning systems, making periodic studies and assessment visits to developing countries in order to evaluate their instrumentation requirements, assess their performance, offer advice as appropriate, and suggest avenues for assistance, evaluating the performance of the tsunami warning system with regard to communications, data networks, and dissemination of warnings, coordinating the development of the observing system which provides the information necessary for the issuance of effective tsunami warnings to those nations wishing to receive such messages. Now, let us see the components of tsunami warning system. You know that it is generated because of the earthquakes. So the first component and the most important component is the recording of the earthquakes at the coast or under the oceans. So seismic stations are deployed all over the region where the tsunami warning system has to be placed. A seismic station consists of a seismometer, which is basically a transducer, then the recording unit and the radios which communicate between the central recording station and the recording station. The signals from the seismic stations are telecasted in real time, and then at the central receiving station the earthquake data processing is carried out. Whenever there is some earthquake, that has to be reported within a fraction of seconds. So the earthquake is located to know the source where the tsunami may be generated, then the size of the earthquake, because not all the earthquakes they generate the tsunamis. Generally the earthquakes which are more than 7.5 magnitude generate tsunamis. And then you have to collect the data from many stations to make fault planes. Since you should know the focal mechanism of the earthquake generated, because only the reverse dip slip faults or the thrust faults, we call them, they generate the tsunamis. And therefore you know that thrust faulting is there at the subduction zones. So most of the tsunamis are generated in the subduction zones. Now after this, once you know the earthquake is generated having a magnitude higher than the one which can generate the tsunami and having the focal mechanism which also can generate the tsunami, a watch is issued to the public. This means that the tsunami may be generated and it may be reaching the people within some time. Once it is confirmed that the tsunami is generated using the tidal gauges or other pressure sensing devices, then a warning is issued and the time is given that at such and such time the tsunami may be reaching the coastal areas. A tidal station is having one or more calibrated instruments called tidal gauges, which are having the capability of measuring the short-term and long-term sea level changes which may be due to the tsunamis or the surges. India is not the member of ITIC because the sources which are affecting those countries are from Pacific Ocean. So if we talk for Indian context, Indian government has also deployed the tsunami warning system considering the two main sources which can generate the earthquakes. The one is Java, Sumatra, Andaman, Myanmar belt, which is on the east as you can see on the map, and the North Arabian Sea. A network of land-based seismic stations has been deployed all along the coast, which is communicating through satellite to the central recording station in Delhi. So whenever there is some earthquake in these two zones, the seismic waves, they propagate to the seismic station, it is recorded, and within no time we come to know about the earthquake size, its location, and the focal mechanism. Once the earthquake is detected, then another network detects the generation of tsunami waves by the pressure sensitive devices. These devices are so accurate that in the depth of 6 kilometers of water, they can measure the changes of the order of 1 centimeter in the water level. So whenever there is movement of tsunami waves, that can be detected by these pressure sensitive devices. Once it is confirmed that the tsunami is generated, the progress of the tsunami is monitored using the tidal gauges deployed at many of the places in the coastal regions. Based on the magnitude of the earthquake, the location, the focal mechanism, the change in the level, and the progress using various instruments deployed, the modeling of the tsunami is done. And once the modeling is done, then you can predict the time at which it will reach the Indian coasts. The warning will be issued for the time at which it will reach, and since modeling is done, it can also predict the run-up and inundation at various places. For this, the bathymetric information, the configuration of the coastal lines, that is all there, and based on which you have to predict the height of the tsunami at the coastal region. And since this data of bathymetry and the configuration of the coastal region keeps on changing, the data is always updated in the data set. Sometimes the refraction of the tsunami waves, it plays very important role, like the damages caused in Nagapattinam. It was because of the constructive interference of the wave refracted by the Sri Lankan coast, which increased the amplitude of the tsunamis at the Nagapattinam. Once the tsunami is detected, then the dissemination of the information to the public is also one of the important aspects. This information can be given on phones, by SMS, by web using internet, or by public systems. Many types of warnings are issued in various tsunami warning systems. So, the tsunami warning is issued as watch. It means that you should be careful. Then a warning is issued and you have to go away from the coastal areas, and then depending on the progress and the direction in which the tsunami is progressing, a cancellation warning is also issued. We have seen how the warning system for tsunamis it works. This figure shows the warning system being used by the member states of ITIC. This shows that if the earthquake occurs in the middle, then after how much time it will reach the coast. The time is given between 1 hour to 13 hours when it is reaching the South American coasts. The locations of the tide stations and the seismograph stations are also shown on the figure, which are used for the warning systems for tsunamis. In these 3 episodes, we have discussed the tsunamis, which is one of the very important effects of earthquakes. Of course, they are long-term disasters, but the damages at the Indian coast, it has proved that we should consider these long-term disasters also. In these episodes, we have tried to discuss and make clear the various terms related to tsunamis, then the tsunamigenic earthquakes, which are the earthquakes which can generate the tsunamis. Then we have seen the damages due to Sumatra earthquake, which is the latest example in this series. And then we have discussed the warning system for tsunamis. These warning systems, they will be helpful in future to mitigate the disaster.